So far, I think with us here, it is about 40 or something.
Yeah.
Hello? كده أحمد جمال هندي.
استنى 40.
شكيل شايف شكيل خش.
Yeah. Okay, I think we better start, yes. Well,
استنى ادخل.
shall we? Okay. Good afternoon, colleagues, the online participants, the colleagues who are present in here, the contributors for the workshop. Well, this is our sixth webinar, and this year it is on challenges of hydrological sciences in arid and semi-arid areas, zones, and the schedule of the webinar, as you have seen in the schedule sent to you, the concept note, would be with an opening remark from His Excellency Dr. Mahmoud Abu Zaid, including the importance of the subjects and welcome and introduction to Professor Wita. And of course, Dr. Abu Zaid now is on the way, and not sure when he would reach here, but Dr. Hussein Al-Atfi, His Excellency Dr. Al-Atfi, will deliver the words which he already prepared. And as you know, that for Professor Abu Zaid is the president of the Arab Water Council, but he is really an outstanding and renowned scientist, and he has so many contributions at the national level, at the regional level, by establishing this Arab Water Council or heading many committees and things, and also in the global level. He is the one who established the first president to the World Water Council, and he chaired the UNESCO IHB Council in one of his very successful sessions, and really many things could be, a book is needed if we want to mention all his contribution. And we are happy that his colleague, His Excellency Dr. Hussein Al-Atfi, will deliver his talk. And Dr. Al-Atfi also had great experience at the level of the national level, the regional and international, and he was also the Minister of Water Resources and Irrigation in Egypt, and of course, he's also really the move behind the Arab Water Council, being the Secretary General of the Arab Water Council, and he has very contribution to the Arab Water Academy. Dr. Mahmoud would be followed his word by the presentation by Professor Howard Wita. And also, I need a day to talk about Howard, his credential at the global level or at the regional level. But I shall mention some, and I'm sure Dr. Hussein also will say some, but I can't say really go without mentioning his contribution to the region in here, to the Arab region. And there are so many contributions, but the ones which I am really acquainted with very much is his contribution in outstanding studies in Saudi Arabia and in the Sultanate of Oman and many Arab countries, which really brought so many information about Arizona and about the water resources in Arid zone. And but I think his great help, which was done to us here in the region, is when I was here in UNESCO Cairo office, we established two important networks. That is the Wadi Hydrology Network and the Groundwater Network. And he, with his late colleague Mike Edmonds, they really, the main founders, I mean, the input which they put from their side is so great that whatever we do, we cannot really express our gratefulness for this work. Also, the success of the Wadi Hydrology Network and the Groundwater Network led the Council of the IHB in Paris to say that no, please go Arizona, not only in the Arab region, and let us have a program which covers this. And Howard was very instrumental with a couple of his colleagues in the establishment of the GWADI, which is a global network for information in arid and semi-arid zone, which really is built on the Wadi hydrology and the groundwater network. In fact, if I want to talk about Howard and what he did in the science of hydrology in arid zone, it would need a book in itself, but I'm sure in his presentation, he will give us something which we can start with, or it can open our way. After that, we will have a picture, which Dr. Tariq will lead us to that, of the participants, and I hope that all of you be present so that we will have this for. Following that, we will have really a comment about this, about the work and about what was done, and we are lucky to have Professor Amin Shorbaji, who from University of Saskatchewan, who would really give us also, I'm sure, a great input for what is presented by Dr. Howard, or things which we think it should have been said, and we will look forward to that. But I will speak more about Professor Amin when I come and talk with him. We are really very grateful for him to be with us. In fact, then we will have discussion, and after the discussion, when we hope we will get quite an input, and we are lucky we have with us Professor Jamal Abdu, from the Dean of the Faculty of Engineering of the University of Khartoum and Director of the Water Research Center of the University of Khartoum, and who already worked in this area. And I'm sure during this comment we will get something from him which will enhance our knowledge about Arizona. And similarly, Professor Abdullah Shigiddi from the University of Sudan University of Science and Technology, and who is also acquainted to the Water Research Center of the University of Khartoum. Among other colleagues, Dr. Tariq, who also worked a lot in the and Dr. Mary. So we may, even for those in here, in addition to you online, we will get some input from him. And then we will end maybe with a final comment and a closing session. So I would like to invite now His Excellency Dr. Hussein Al-Atfi to give us the words on the importance of this subject and on this, our guest, our main guest, Professor Howard Ouida. Please, Dr. Hussein.
Thank you very much, Professor Abdin. Good afternoon, distinguished participants and guests, esteemed colleagues, ladies and gentlemen. It's with great pleasure that I welcome you all, both at the Arab Water Council headquarters in Cairo, and those joining us virtually from across the globe, to this important and timely webinar on challenges for hydrological science in arid, semi-arid regions. So on behalf of the Arab Water Council and His Excellency Professor Dr. Abu Zaid, the President of the Arab Water Council, and in its affiliated knowledge arm, the Arab Water Academy, I extend to each one of you my warmest greetings and my sincere appreciation for your participation in this important event. I am particularly honored to acknowledge our distinguished keynote speaker today, Professor Howard Ouida, as a world-renowned expert in the field of hydrology, whose contributions and his effective work have advanced the science and the practice of water management worldwide, and especially in arid regions globally. I take the opportunity to thank the Professor Abdin Saleh, my friend, and Professor Dr. Jamal Abdu, Professor Abdullah, of course, my old friend, Dr. Amin, to be with us today. I believe that the science of hydrology in arid and semi-arid regions remains at the forefront of both opportunity and the challenge. Despite decades of research, hydrological science in arid and semi-arid regions still faces fundamental and unresolved challenges. We continue to struggle with understanding the complex process, developing the hydrological models, integrating surface water and groundwater research, harnessing emerging technologies, from advances remote sensing to AI-driven modeling to improve prediction, monitoring, and decision-making, translating the cutting-edge science into practical policy-relevant solutions for water managers and decision-makers. So I believe the advancements in remote sensing, geospatial analysis, data assimilation, and coupled with surface groundwater modeling hold a promise here. So the role of Arab Water Council here, through its affiliated Arab Water Academy, is committed to bridging the gap between science, policy, and practice. So our aim is to foster capacity building, promote the knowledge exchange, and advance collaborative research across the Arab region and beyond. So we believe that strengthening hydrological science for arid and semi-arid regions will help us to achieve the following: the better anticipate and manage water-related disasters, support integrated water resources management strategies tailored to arid climates, enhance resilience against the impacts of climate change, ensure that scientific advances translate into real benefits for communities, ecosystems, and economies. Also, another very important issue is that water management across the region. I mean, a cooperation in regional level, that's such as shared water, hydro diplomacy, and water diplomacy. So our mission is not simply to advance hydrological science for academic purposes, but to place it in the service of human resilience, environmental, and sustainable development. So with this, I'd like to let this webinar to be more than a platform for knowledge exchange. Let it be a catalyst for partnerships, for innovation, and for evidence-based actions. The challenges before us are significant, but so too is our capacity for collaboration and progress. Once again, I thank you all for joining us. I wish you all a productive and inspiring webinar and look forward to the valuable discussions and recommendations that will emerge today. And once again, let me thank you all. And it's now my honor to give the floor to our esteemed keynote speaker, Professor Wheater, to start his keynote speech. And the floor is yours, Dr. Abdin.
Okay. Well, thank you very much, Hussein, and for this very very good introduction for the subject. And for now, Howard, I'll send you really the floor and to here for the part which you are really going to give us and put us inside the hydrology and its challenges and its future in Arizona. But Howard, what is yours?
Thank you very much, and thank you for those inspiring comments. Can you hear me? Hello?
Yes, we are hearing you.
And you see me? You see the
Yeah.
Yes. Okay, great. Well, it's a real pleasure to be talking to some very old friends in Cairo. It's a long time since I've visited Cairo, but I had a very memorable meeting a few decades ago, hosted by the ministry and taken out to see some important research sites in the Sinai and elsewhere. So as you'll gather from the introduction, I have quite a long history of connection with the Arab region. And I'm going to talk to you about my experiences and what I've learned, and some more up-to-date research, and talk about the major challenges that we face. So hopefully those of you of younger generations that are attending will find scope for some inspiring research and some promising new careers. Okay. Now, so I think we all know that the hot deserts of the world are the places where water is most scarce. But I don't need to tell anybody in Egypt that there are real challenges associated with water management. So we see rapid economic growth, rapid population growth, and with climate change, extreme events are becoming more frequent and more damaging. So we need appropriate water management, but that really has to depend on understanding the hydrology. And there are very well known problems that remain unresolved, really around the limited data and gaps in our scientific understanding. Such a lot has been written in hydrology about the processes that control the hydrology of humid areas, but relatively little has been written about the particular challenges of arid zones, and they're often poorly appreciated and result in real challenges for modeling and management. So around the world, we're accustomed to using models for flood design, flood forecasting, water resources management. But very often those models are developed for quite different regions and quite different purposes. So we really need to be aware of the limitations and the challenges when we seek to model arid regions. Oops. So this talk is really focused about the science of wadi hydrology and the scientific gaps and also the modeling needs and challenges that arise. So a very long time ago, I was sitting in an office in London and I had a phone call asking me if I could come out to Oman to assist because there had been a major flood in northern Oman. And this was to be a life-changing event for me because I discovered the excitement and the challenges of hydrology in arid areas. Some of you in the room will know Oman very well, others won't, but you'll see from the map in the center that there's a mountain range, the Al Hajar Mountains rising up to 3,000 meters. There's a set of wadis that run off towards the coast, towards Iran, and a set of wadis that run into the interior of the Arabian Peninsula. There's very interesting traditional development of water that's widespread in Oman, the Al-Falaj system. So this is where hand-dug tunnels channel near surface water tables above ground and then provide the water for irrigation for local communities. So 1981 was an interesting time in the history of Oman because, as many of you will know, Sultan Qaboos had relatively recently come to power. The country was developing rapidly. A lot of work had been done on water resources, but relatively little attention had been given to floods. And in fact, the responsible body was the Royal Oman Police, for whom I was working. So 1981, the May 1981 flood was damaging. It caused a lot of infrastructure damage. It caused some loss of life. On the left, you'll see the main road that linked the north and south of Oman. So there's a classic example of a set of culverts at right angles to the flow. The flow just kept going and wiped the road out. The other diagram picture on the right is interesting. There was a brand new completed road before the storm, and after the storm, all that remained were the culverts. So a lot of damage and very little background work that had been done to quantify flood risk and provide the material needed for flood risk management. So we gathered together, I put a small team together, we gathered all the available rainfall data, and the map on the right, apart from being an example of what graphics looked like in the 1980s, which is rather different from today, shows a rather optimistic set of contours around a sparse set of rain gauges. And the main catchment that was affected in the center, Wadi Aday, received just over 100 millimeters of rain, and the temporal profile on the left shows that that was in just a couple of hours. But you'll also see that the most extreme rainfall was off to the right, Kuriat, 140 millimeters, and there was another burst off to the left, another 100 millimeter recorded. So we see this spotty rainfall with very intense bursts causing extreme damage. There was one flood gauge in the affected area, and that was never seen again after the storm. Just to give you some context, the annual average rainfall in Muscat is around 106 millimeters, and you'll see that a wet month typically has 1 or 2 rain gauges. So this storm was already more than the annual rainfall in just a couple of hours. So we put together a classic analysis of the short-term rainfall data, looking at the return periods of different durations of short duration rainfall. And then we worked to produce some guidance as to kind of runoff characteristics. And we built a simple model that represented the arid zone hydrology by overland flow on cascaded plains feeding into a channel and then the flood routing down the channel with infiltration. We didn't have observations, but when I was there, I organized a survey of the high water levels. We reconstructed an estimate of the peak flow, and the police records allowed us to then reconstruct the shape of the hydrograph with the first peak and then a second major peak. So we were able to use that to define the parameters of our model and then use those to produce some design guidance. So that was a flood analysis which stayed in place for quite a long time. Probably, I think I understand about 20 years. And of course, it was an extreme event, but Oman is not a stranger to extreme events. So in 1977, Mazira Island off the Oman coast received a daily rainfall of 430 millimeters. And then most recently in Cyclone Gonu, 2007, the maximum rainfall reported was 960 millimeters. So nearly a decade's worth of rainfall in a storm. So this characteristic of arid zones is that while water is limited, extreme events really are very damaging and dangerous. So for me, coming from a humid background, it was a rapid learning curve. I realized that it's not uncommon to receive a year's rainfall in a day, and that the water balance is really dominated by these rare events. So, for example, the groundwater recharge from an extreme event might be the most important recharge over a decadal period. Clearly, hydrological monitoring is extremely challenging. We've seen from that slide that the spatial rainfall was variable and very difficult to capture with the sort of gauge networks that we typically have. And flows are extremely difficult to gauge because when the floods come, they're very damaging. So the only flow gauge in that event was washed away and lost without trace. And something else I learnt was that traditional knowledge can be important. So the streets of Muscat, the old city, the older properties were all built with raised doorsteps, so raised entrances. So they were accustomed to the streets flowing as wadis in extreme events. But that knowledge had been lost and a lot of property was damaged during the flood. Even the Royal Palace had some water ingress in Muscat. And there were quite important new developments of housing that had been located in flood-prone areas. And just as a footnote, I was to return to Oman a few years later to work on recharge dams. And there, it was interesting because the knowledge of the traditional affoulage systems had been overlooked, and recharge dams were being proposed for the interior of Oman, where the existing foulage systems were really effective, very effective way of maintaining a sustainable water resource. So that was a rapid learning curve for me. I was then very fortunate just a few years later to be invited to work in the Kingdom of Saudi Arabia. And there was what was, in my mind, a really pioneering study funded by the Ministry of Agriculture and Water called the Five Wadi Representative Basin Study. So these were 5 basins ranging in area from just under 500 kilometers squared to nearly 5,000 kilometers squared along the coastal mountain range, mostly draining to the Red Sea, but some draining to the interior. And the important thing about this study really was that there was quite intensive instrumentation, and each wadi had a permanent team of observers who lived there throughout the year and were available at a moment's notice if an extreme event were to occur. So there was a very high quality of data. So each basin typically had something like 20 rain gauges, many groundwater level monitoring sites, and a classic WMO climate station. So the mountains of southwest Saudi Arabia are very beautiful, up to 3,000 meters. This was one of the rain gauges in the study, and you can see the rugged topography and then the flat wadi floor. Water resource development in the region at that time was hand-dug wells, as you see on the right, and also some construction in some basins of temporary earth dams that would capture the water in the first flush of a flood and direct it onto the fields, and then be washed out to be captured by another dam lower down. This is a slightly embarrassing story for the study because you can see a wadi channel, and a flood came down here of about 3,000 cubic meters per second and wiped out the previous monitoring station. So this was the magnitude of the station that was built, and you can see the scale from the right-hand picture with the observer just clearing the float at the bottom of the gauge, but really massive flows coming down these wadi systems. On the top left, you can see the typical pair of monitoring wells for pumping tests and alluvial groundwater, shallow groundwater monitoring. And then on the right, the classic WMO Met station. So what did we observe in terms of responses? Well, a lot of valuable data was gained from the 4 to 5 years of record for which the study was run. The top left shows intensive overland flow. So in humid areas where most of the hydrology textbooks are written, overland flow is a rare occurrence in vegetated soils. Here we've got soils which are desert soils. They appear to be quite permeable, but in these intense storms, they generate a lot of overland flow. Of course, that transmits itself extremely rapidly into a stream network. And then the other slides show the passage of a flood wave moving down a dry wadi bed. And an important feature to note is the sky, because you can see there are no clouds. It's a sunny day. The rain has already happened, and this flood is moving at a walking pace or a running pace down the wadi. Very dangerous situation for people who use these wadis for transport and are located near them. So clearly, a major issue is the transmission of these floods, because the floods infiltrate into the wadi bed. The bigger the flood, the further it travels before it's dissipated. And that, of course, is a major source of recharge for the underlying groundwater systems. Very poorly understood, very difficult to monitor and capture. This is a slide on the top left, which illustrates some of the complexity. So this is a recession from a flood, and you can see a shiny surface on the wadi bed, and that's a little thin skin of fine particles. and the water that's flowing is perched on, by those fine particles, it's perched above the sandy underlying unconfined aquifer. So we dug a hole next to the flow. The hole is dry. There's no connected water table there. So that flow is just perched along this little skin of fine sediments that at some point in the recession flow is deposited. So we've got a very complex set of processes with bed mobilization, a lot of sediment transport, and then progressive settling of the coarse and then the fine material sealing the surface. After this flood is finished, the fine particles will dry, they'll crack, and they'll blow away, and we're left with a sandy bed once again. So as part of this study, to try and understand these processes, we put in a neutron probe access tube for measuring vertical profiles of soil moisture so we could capture the wetting front from a flood. But of course, the flood didn't happen. So we conducted some infiltration experiments around that neutron probe access tube. And these are written up in some publications from the 1990s. And we found extremely high apparent permeabilities of the soil. In fact, the soil appeared to be so conductive that we really didn't expect that a flood would propagate. So clearly, taking measurements in a dry bed is giving quite an unrealistic picture of what the effective parameters are for infiltration. So this is another of the major challenges. Just turning to the rainfall for a moment, this is one of the basins, 3,000 square kilometers in area. And you can see the daily rainfall for one particular day's storm. And the basin's bottom to the left of the diagram has 0 rainfall. And if we split that up into hourly rainfalls, then the first hour on the left, we've got a little burst of rain in the top right of the catchment, nothing anywhere else. We then have a relatively quiet second hour, and then we have a third hour with another burst and a fourth hour. So very patchy rainfall, just as we were talking about before, very difficult to capture. In fact, there were floods that occurred with no rainfall. The rainfall had fallen between the rain gauges. So some interesting results from a typical set of groundwater monitoring wells and gauging stations moving longitudinally down a wadi. And you can see that, in fact, some of the flows at the bottom of the wadi occur before the flows at the upper part of the wadi. So we've clearly got rainfall falling at the bottom of the catchment before it falls at the upper part of the catchment. You can see some fairly significant groundwater responses to those flows, but they vary depending on the hydrogeology. And then if you look at the groundwater level at the bottom of the catchment, at the bottom of the picture, then it's difficult to detect any of the activity that's been going on upstream. So again, one of the real challenges of these systems is that we measure something at a point, and that on its own can really not tell us of the complexity of the processes that are going on upstream. So that's another major difference from humid areas. If we measure a flow in a humid area, we usually assume that's a collection of the flows from upstream. Here, it most certainly isn't. Here's a small subcatchment of one of those basins, Wadi Gat. You look at the 10-kilometer scale. So we've got 5 rain gauges to capture the spatial rainfall, and we have a flow gauge. So let's have a look at some of the relationships between rainfall and flow. So we've got the runoff volume on the y-axis, the rainfall volume on the x-axis, and you can see that the largest runoff comes from the smallest rainfall. So one of the conundrums of spatial rainfall in arid areas is a result like this. So clearly, even though we've got 5 rain gauges, we're not adequately capturing the spatial rainfall as it falls. There are some results that are consistent. So the next slide shows the relationship between the peak flow and the runoff volume, and that's very consistent. So these sharp peak hydrographs have got quite a consistent shape. So I think this is a very important study. It was a really pioneering initiative by the Saudi government. The only pity was that it didn't continue for longer. It's illustrated the issues that I've been talking about. Spatial variability of precipitation is so important, but very hard to characterize. Overland flow, we saw, occurs extensively. It's a dominant process in runoff generation, quite unlike humid areas, where the only overland flow tends to be from tarmac and concrete. But the effect of surface processes on infiltration are relatively little studied. So we see what are apparently quite permeable surface soils, but in practice, with that raindrop impact, they seem to be sealing and generating a lot of overland flow. Wadi flows themselves are very dynamic. They can be dangerous. They tend to reduce with distance downstream, and we've seen that they are unreliable indicators of the upstream flow. And yet it's these flows that are often the most important source of groundwater recharge. So these transmission losses from the flows are important, but the processes in the stream bed are quite complicated. We've got bed mobilization. We've got a flood moving down a dry wadi bed and infiltrating. We've got quite complicated hydrogeology underneath that. And it's really hard to characterize those processes effectively, both scientifically and in modeling. And of course, groundwater recharge is the key for sustainable resource development, and yet it's really hard to estimate the groundwater recharge given these surface processes that we've just seen. So here are some lessons from the Arabian Peninsula. For a long time, people have written about the challenges of arid areas and how limited the data are, and there's a set of papers there going back to the 70s and 80s. And really, it remains the case that around the world, there are some isolated studies, but there's very little detailed, intense monitoring at the kind of level of detail that we need to understand these very complicated processes. One exception is quite near where I live now in the winter. I live in the winter in Phoenix. But down to the south of Arizona, there's an experimental site called Walnut Gulch. And that was uniquely established in the 50s by the US Department of Agriculture. It had 88 rain gauges, 11 critical depth flumes, and it's been running since 1953 and continues to this day. So it's a fantastic data resource, and I've given you a reference there to a story about the first 50 years of research, which was published in 2008. So let's have a look a little bit at Walnut Gulch. This is the network of rain gauges, nearly 100 in a basin that's only just over 100 square kilometers in area. But let's have a look at the rainfall. Now we've got some detailed images that I'm going to show you, and they're just a few minutes apart. So this is 2nd of August 1957, 16:32 in the afternoon, and there's a little burst of rainfall, quite intense, over a very small part of the catchment. We move from 16:32 to 16:38, 6 minutes later. That burst has intensified and expanded, but still it's limited to a small portion of the basin. We move from 1638 to 1643, that burst is dissipating, and then 1647, that's the end of the storm. A little burst on the opposite end of the basin, but that's it. So once again, we've got this pattern of very localized rainfall. Okay, I'm going to come back and talk about some of the implications that for modeling in a moment, but I just wanted to mention in passing that there are a couple of other detailed data sets which I've been involved with, which are quite interesting. The first is quite recently. There was a dispute between Chile and Bolivia, which came to the International Court of Justice in 2023 to do with a small river called the Salala. And because this was such a high-profile dispute, Bolivia was claiming that Chile was stealing its water. Both sides invested quite a lot of resource in monitoring the processes, the precipitation, the flows, multiple sites, spring flows, groundwater levels, pumping tests, a lot of work on evaporation processes and wetland responses. So quite an important site, although it's a cold arid region rather than hot arid region. But it's an example of a unified study with a lot of surface and groundwater studies to unscramble the complex hydrological processes. Another rather different site, which is a salutary story, is Yucca Mountain in Nevada, which was proposed and still is proposed as a nuclear waste repository. And the US Department of Energy has spent $10 billion investigating this site with no conclusion at present about its suitability for deep disposal. But I've written about this in an article recently, which summarizes most of this talk, incidentally. And the US Geological Survey was responsible for the hydrology at Yucca Mountain, and they reckoned that to monitor the precipitation, they needed a really dense network of the order of 100, 150 gauges. And in the end, they finished up with just a few. So one of the major criticisms that I have of these studies is that the surface hydrology is very poorly understood and poorly characterized, despite such a very large sum of money being built to understand the fracture flows in the mountain. Okay, so just to say a few words about the modeling challenges, and I'm going to start off by coming back to Walnut Gulch. So a very good friend of ours, Sarush Sarushian, who was a founder of the GWADI network with Abdeen and myself and Mike Edmonds. Sarush has done quite a bit of work in Walnut Gulch to look at the effects of rain gauge density, rainfall capture on models. And he was able to show that if you use fairly well gauged basin, 1 gauge for every 20 kilometers squared, then you are still going to have major challenges in capturing the rainfall, and your estimates of flood peaks will be 50% in error. And similarly, at that time in the 90s, the best radar data was 4 kilometers, and even a 4-kilometer radar would lead to 50% errors in simulating peak flows. So the rainfall capture problem remains. More recently, there's been some quite interesting work done by Melez et al. And Saman Razavi, a colleague of Amin El-Shabagi and mine at Saskatchewan. So there's a set of new techniques that allow us to look at model parameter sensitivity and how that varies in time. And they did some interesting work at Walnut Gulch to show that actually the model parameters sensitivity depends on the structure of the rainfall. So if you've got a rainfall occurring in the headwaters, then the model will place more importance on the parameters that control flood transmission downstream than if the storms occur towards the lower part of the catchment. So some insights starting to come from these quite powerful methods of model analysis. And coming back to Oman, just to illustrate the modeling challenges, I'm going to present some work of a lady that some of you will know, Aisha Al-Qarashi, who did a PhD with me in London on this. And she looked at a basin in Oman and tried to simulate the flood response. It's called the Wadi Ahin. The upper part of the basin, it's about 730 square kilometers. The basin's quite well served with rain gauges. This is on the coastal plain, feeding water from the Oman mountains towards the coast. And she set up a model which was developed for Arizona called Kinneros, one of the most widely used surface hydrology models in the world now. It represents the flow as a cascade of plains into an infiltrating channel. And she did some quite sophisticated modeling using Monte Carlo simulations, looking at 27 rainfall events on that basin. And I don't want to spend a lot of time on this, but the interpolation of the rainfall has a dominant effect on the kind of response that you simulate, as shown here. If you use different performance criteria for the simulations, you get quite different results. And then the bottom slide is interesting because if you take the best parameters from each of the 26 other events and apply them to this event, you get a massive spread of variability. So the parameters are not capturing the true variability of the process response. And that's partly due to the rainfall problem. And I think I'd argue it's partly due to the difficulty of capturing these flood generation and flood transmission processes. One of the things that she did was to then build a regression model, very simple regression model, the flow peak as a function of the rainfall volume, the flow volume as a function of the rainfall volume. And the moral of this story is that simple linear regression gives a better fit and a better predictive tool than the rather complex simulation models. Okay, so we've been through quite a lot of ancient history. We started in the 1980s in Oman and Saudi Arabia. We've talked a little bit about the lack of data. We've been to Arizona and seen that there's a lot of work going on in the world's best monitored experimental basin. Where are we now in terms of understanding these complicated processes? So if we think about infiltration, then we've got these desert soils which seem to generate very large amounts of overland flow. And the first person that I've found writing about this is Morin and Benjamini, publishing in the 70s. And they showed that the impact of raindrops, the intense rainfall on surface aggregates, was to cause pore blocking and and reduced permeability and hence extensive overland flow. And there's similar results from the Sahel. Other people in Europe and China have also published about biological crusts, which have similar effects. So there's some indication from the basic science that there are complicated processes, but really they haven't been understood to the level that they can be effectively used in model quantification. Let's turn now to the Wadi bed and transmission losses and the groundwater recharge. This is critical because it's the flood risk being transmitted downstream, and it's a major source of groundwater recharge. But incredibly difficult to capture because the floods are so infrequent and they're so damaging. So simply getting basic data is challenging. Remember, I told you the story of in Saudi Arabia, we instrumented a wadi to capture these processes. There were no floods that year. Very difficult to set up a PhD study to understand these processes, for example, when you need to get results within a 3, 4, or 5 year timescale. So very challenging events to monitor. There's some interesting work done by Dahan in a river reach in Israel, where he did some very detailed monitoring, measuring the flows, looking at the unsaturated water content and the groundwater elevation and conductivity. And he had some interesting results. So actually you need some minimum head to break through capillary barriers in the layered sediments. He observed what we'd observed in Saudi Arabia. If you do a ring infiltrometer test on a dry bed, you're going to grossly overestimate deep infiltration. even if you've got soil moisture sensors, you're going to be missing elements of fracture flow. And he also found that reduction of the upper layer conductance occurred, as I showed in those early photographs, due to fine sediment particles clogging the pores. A little bit more work by Dahan in Africa, in Namibia, looking at slightly larger scale, but some quite interesting insights showing, although it's an apparently permeable bed, the actual infiltrates are relatively low, and you've got this lenses of fine sediments blocking the infiltration process. And some interesting implications for modeling. So there's a paper that Australians wrote in 2014 reviewing this challenge of estimating groundwater recharge and transmission loss. And they came up with a few important messages. First of all, you measure on a dry riverbed, you're going to overestimate infiltration. If you take profile measurements of moisture content, you get insights, but be careful because you're not capturing lateral flows from the Wadi. And once the profile is saturated, you won't get any useful information on fracture flow. Often people try and look at water balances in reaches, but those are subject to quite large errors in measuring the flows, errors in estimating the inflows in the reach, errors in estimating evaporation losses. It's possible to look at a flood wave and track it, but again, that's very sensitive to channel geometry and modeling assumptions. And then, of course, you can look at the groundwater response, but interpreting that response means that you need to know a lot about the aquifer heterogeneity and its properties. People have used groundwater dating, but again, that's a rather broad brush technique that requires a lot of assumptions. So all of all, there is no perfect solution to estimation of transmission loss from groundwater recharge. It's an ongoing challenge and one that needs really a lot of detailed information, which by and large we don't have. So I've talked a lot about processes and history. I just want to say a little bit about remote sensing. And I now, in the winter, live actually on the campus of Arizona State University. And a good friend and colleague, Enrique Vivoni, has a hydrology team there. And they've been doing some quite interesting work on remote sensing of arid zone flows. And I don't want to spend a lot of time on this, but this is to do with Planet Lab, small satellites, a constellation of CubeSats. So loads of satellites, quite high frequency of spatial and temporal monitoring, and high resolution, up to 3 to 4 meter resolution. And if you measure the reflectivity, then you can tell whether soils are wet or dry. So just one example from a river just to the west of Phoenix called the Hassayampa River. This is a flood event, and we want to look at the flowing river sections. And so you can see that on the right, we've used remote sensing to delineate the channel width. But the really interesting diagram is this one. So this diagram shows time on the bottom axis, and on the y-axis, it shows the distance upstream, and the shading indicates whether the channel is flowing or not. So it's an extremely interesting picture of a very complex system where you can see that there are some time periods where there's some perennial flow at just a couple of locations, and during storm events, then reaches kick in for relatively different periods of time and different durations. So it's a very powerful image there, which gives us a lot of insight into the surface groundwater interactions. And this is kind of a new kind of data, and as far as I'm aware, it's not really been fully assimilated in integrated surface groundwater modeling, and it'd be very interesting to do more work along those lines. Okay, so let's wind up with some conclusions. A few slides of these. Firstly, well, we need improved science and appropriate training, and Abdin Salih has already mentioned GWADI. UNESCO has this program. It's an important forum for exchange of information, and it continues to this day with regional activities. And it provides some data sources, including in particular rainfall products. We've looked at research going back 40, 50 years, but still we've got some really important challenges to understand these processes. We need intensive studies. They have to be multidisciplinary to unravel these process complexities. And it's very challenging and very resource intensive and difficult to fit around traditional graduate training programs because of the infrequency of these events which so dominate the water balance. What are some of the scientific challenges? Well, clearly spatial rainfall, understanding infiltration, evaporation, and overland flow, understanding wadi bed infiltration during these floods, understanding the interactions with the aquifer. And I've rather focused here on streams recharging the aquifer, but typically we have complex hydrogeologies in these systems, and we can see regions of flow emergence as the groundwater moves downstream through hydrogeological barriers. Understanding groundwater recharge process is critically important, and I focused in this talk on wadi bed recharge because that's often the most important, but by no means is that always the case, and certainly fracture flow in mountain block environments can also be extremely important, and indeed in Yucca Mountain that's the dominant concern. We've touched very briefly on remote sensing, so lots of new data sets coming available, and these have yet to be fully exploited, but nevertheless, we still need dedicated field observation and experimentation. In terms of modeling, we've got computing power. We can do complicated things now to interrogate models and understand parameter sensitivities and their identifiability. But we've only just really started to scratch the surface in recent papers and applying these to the particular challenges of arid areas. Excuse me. There's relatively little methodological research been published, and very often models developed elsewhere are used with rather limited data and often with limited critical assessment. We have to be very conscious of their potential limitations. The one model that has been designed and is quite widely used is the US Department of Agriculture Kinross model. But with that, we need more experience of the parameter values, their relationships to catchment characteristics, their dependence on scale, their uncertainty, issues like the dependence on rainfall location within the catchment, and so on. And for conceptual models, we need to develop local experience so that we're confident about using appropriate parameters. As I briefly mentioned, there are some quite important new methods of sensitivity analysis, and including looking at time variant importance of the parameters, and those offer significant potential for improved insights. Rainfall is a critical problem, and handling uncertainty in precipitation inputs to hydrologic model is absolutely a major challenge, and there isn't really a good solution. We are seeing improvements in radar definition. So that's down to kilometer or sub-kilometer level now, and that's extremely promising. And there may be opportunities from high resolution atmospheric modeling, but that has all yet to come together. So maybe we need to get better handle on stochastic models so to simulate extreme events and hence potential flood risk. So this is the final slide. we've got huge challenges for management of water in arid areas, but these are the areas where water management is most important, fundamental, life depends on it. And we really need to do a lot more work to build our experience, to sort our understanding and our model applications. We need good quality data. That's expensive and very hard won. We need to be aware of the potential of new modeling tools. We need to develop a core of expertise locally and regionally through organizations like the Arab Water Council, GWADI, and to share knowledge and experience between the world's arid regions. So thank you very much for your attention. I have published a paper recently which summarizes a lot of this, 2025 in Environmental Modeling and Software. There are 2 books that UNESCO produced based on GWADI, and the GWADI website has further information. And at the end of this talk, I've included a list of references which you can check out if you're interested in more detail. So thank you very much for your attention. I hope that there's something of interest. These problems and challenges are important, but they're exciting. And I hope that many of you will have fruitful careers following up with these. Thank you so much.
Thank you, Doctor. Can you ask some questions?
Thank you very much, Howard. And I feel really more frightened than in 1996 when we started the Wadi Hydrology Network, and with your help and tried to sit and see. And I can see even the wisdom when we try to start pilot schemes in different wadis in different countries, in Sinai, in Morocco, and we did not push this very much, and it did not work on that. Even when I see something like the 5 Wadi program in Saudi Arabia, that it is stopped in 5 years. It may have increased the knowledge a little bit if we continued. And I always called with my colleagues in Jeddah University, in Abdulaziz University, why didn't you go? And that is a very good laboratory. Go there and bring more young people interested in this subject, which is very important. And especially with climate change now and with the problems which are related to Wadi. Now I'm really frightened when I saw what Howard said and the conclusions and things that what we started in 96, I hope that if we pushed it. We did, as you remember, Howard, something also on the Wadis in a general way in Saudi Arabia with Dr. Tarbag and with Denai, and we selected 2 Wadis in central Saudi Arabia, which is different than the geography of Western Saudi Arabia. But also, it did not continue. It is true with remote sensing, with this development, and I agree with you totally, without having also experimental work. We have some people who are dedicated to this type of work. And I really, I mean, you have done your share very well, but I think we should use your conclusion really as a direction of we should really bring more people to work on that, to more attention to the importance of those challenges and how to do with this. In fact, it is more difficult now with the effects of climate change. I think before we go to the comments and commentator by Professor Amin, I think in the program, we need to take a photograph, a joint photograph. So if the participant open their cameras so that we will have a joint photo, but we assure you that we will send you this presentation because it is a valuable presentation. And I think we need to see how it reaches a lot of people. Thank you very much, Howard.
Thank you for those kind words. I agree with you entirely, Abdin.
Sam, how are we going to this with Tariq?
Need to mention.
Yes. Pardon?
Need to mention.
Open your picture.
Please open your picture so that we can see. And we can see Dr. Mahmoud is there. Have you? Yeah. Okay.
I think our camera can't open my video, my camera, because it says like the host has stopped the video. So could you please maybe release?
Same طب شكيل أحمد decide. Okay. Oh, I think this song.
Is it all right sound? Okay. Okay.
ميد عليه.
I'm so happy that I can see in the picture so many young faces, which really, I think it is very important for you to learn what is needed really. And I think the subject of hydrology and water resources and zones need your efforts, I think.
Yeah. Uh-huh. Yes.
Yeah, thank you very much.
Yes. It's okay.
Thank you very much. Yeah, it's working now.
Yeah.
So is it okay?
Thank you very much.
Well, thank you very much, everybody. I think now we move towards the next part of our program. And we are very happy indeed to have with us Dr. Amin Shorbaji. Dr. Amin is a PE engineer, is an emeritus professor of hydrology and water resources engineering in the University of Saskatchewan, Canada. His research focuses on and link to the areas of watershed hydrology, water resources system, and decision analysis through various modeling tools and techniques to support decision-making process. Dr. Shorbaji work on water resources management to address the challenges of sustainable utilization of water resources under current and projected future hydrodynamic conditions. Water energy and water energy food nexus has been an emerging theme of Professor Shorbaji's recent research at the second generation approach of managing integrated water resources, including water. His application areas include professional, provincial, national, regional, and transboundary river basin. Dr. Shorbaji was invited to deliver talk and keynote speeches at various international conferences and universities worldwide, as well as to industry and government in Canada. Dr. Shorbaji published over 200 publications in international journals and conferences, supervised, advised over 70 master, doctoral, and postdoctoral researches. We are really very happy to have you with us here, Professor Amin, and also I would be very grateful to Howard for really introducing Professor Amin to us, and to Khalid, Dr. Khalid Abu Zaid for creating the link. Now the floor is yours, maybe. It's there.
Thank you very much, Dr. Abdin, for the kind.
Sorry, I'm not getting any sound.
Okay.
Okay.
Yes.
Okay.
Should I repeat?
شغال. ايوه ما دام مدي اخضر.
Okay, in case I was not heard well, let me just repeat what I was trying to say. I would like to start this brief comment by thanking Howard Wheater for a very rich lecture and very relevant content to this region indeed. So I just wanted to highlight a few issues just to kind of summarize. Of course, Howard really doesn't need anybody to summarize what he says, because he summarizes it very well. But I want to just highlight that Dr. Wheater picked the key issues, of course, of the need for improved quantification of spatial rainfall, infiltration into desert soils, and groundwater recharge from ephemeral flows, and the issue of integrated assessment of stream flow aquifer interaction. Dr. Wheater also, I think, touched on the issue of local knowledge. Sometimes as scientists, we ignore that. There will be a lot of knowledge embedded with the local people, whether they say it or whether we observe what they have done in the past to learn how they actually interacted with their environment, and in particular water, because we can learn a lot of things from that. One of the things that really comes to fore here is that the issue that it sounds local field condition, but it's very important and vital for arid region hydrology. The issue of hydrophobicity or crusting of bare soil leading to surface runoff over dry topsoil layer. This is something that most, if not all, hydrological models actually will not be able to capture, indeed, unless we find a way to insert some of this to the model parameterization. So it seems that process representation and parameterization is a dominant issue, which highlights the potential use of simple and also one of the issues regarding hydrological modeling, those who did hydrological modeling, they understand this very well, that all hydrological models suffer a lot from what is called extended periods of hydrological silence. When there is nothing happening in the watershed, watershed models typically fail. So in arid regions, of course, there is hydrological silence most of the year, and sometimes more than one year, and that's why many people resort, as Howard highlighted, that to the event-based models. Once you kind of skip continuous hydrological models and move to event-based modeling to focus on the flood, then there is no wonder, of course, that we miss key issues as groundwater recharge, as most event-based models are not equipped and developed to actually quantify such a phenomenon as groundwater recharge. The field conditions, as I mentioned, based on what Howard said, physical and biological crusting affecting infiltration. We have issues for transmission losses. Extensive bed mobilization occur under relatively low bed shear. Detailed monitoring is really a big challenge in arid regions, even though remote sensing can help a little bit, but nothing can really replace detailed monitoring and field observations. So I just wanted to extend what was just said to mention that there has to be a way to augment remote sensing data with gauge data to create some kind of good fine resolution rainfall maps, because spatial rainfall is really an issue in arid regions. It is important to get to some emerging techniques now in machine learning, in causality techniques. We can use such things to try to learn what is happening in watersheds where we don't have enough knowledge. But of course, unfortunately, such techniques require extensive data sets, which is another obstacle here. So it seems that we have to talk a lot about challenges and obstacles, and we might have to rely on new generations to come up with solutions. So if we focus more on the Arab region, then one can summarize challenges as follows: scarcity of research and expertise, a shortage of specialized hydrological scientists and research, especially among newer generations, and funding constraints. Unpredictable climate patterns complicate hydrological models and forecasts, making water resources management more difficult. Collaborative research is often hampered by tensions affecting comprehensive understanding of shared water systems and shared problems. Limited access to advanced hydrological modeling tools and infrastructure restrict effective analysis and decision making. And I would like to note here that sometimes we don't need to start always from scratch. Many of the Arab countries have access and membership to institutions and organizations like the IASA in Vienna, where a lot of expertise, a lot of modeling tools are being made available, and sometimes they just need some sort of adaptation and modification to fit into the conditions we are interested in, and we need to leverage such things. And finally, unregulated land use change, whether it is urbanization or agriculture and land degradation, all these things affect even the watersheds that we already understand, let alone the ones that we don't understand very well. With this, I think I would just conclude my brief comments, and I would like to thank Howard again for the very rich lecture that he gave today. Thank you.
Thank you very much, Professor Amin. I think really you added quite a lot to what Howard did, and also it made one very frightening and exactly the challenges which mentioned by Howard and now mentioned by attended. I think need really to think of this subject as a very high priority. I mean, we really, especially in Syria, and also we take this from you, and also you can send it to us in I think we may need to send it to the participant and other than the participant. I think also before I open the floor for open and discussion, with us there are two also scientists in this room, Professor Jamal and Professor Abdullah. So if you have something to add, I think it would be good to hear to you, especially both of you, at least you, Professor Jamal, work with Howard. Also.
Thank you very much, Professor Abdin. Thank you very much, Howard. So good to see you after a long time. I'm proud to have been one of your students 45 years ago. So thank you very much for your excellent lecture, which you have covered a very important aspect of wadi hydrology and wadi water resources management. I really appreciate your outstanding contribution to the area of arid zone hydrology and arid zone wadi hydrology and physical processes in arid and semi-arid areas. I also take this opportunity to extend my appreciation to the Wadi network for its outstanding contribution to capacity building in arid zone hydrology and in supporting the studies in Wadi hydrology, and also in providing information such as the satellite-based data. I think you have covered many important aspects and also many challenges of water resources management in other systems, which you are all facing in our countries as researchers. I think there's a lot to be done. A lot of research is needed in this field. But unfortunately, one of the biggest challenges we have is availability of research funds and also availability of data, especially regarding transboundary wadi water resources management, because we have a number of wadis which are shared, and most of the catchment of the wadi lies outside the Sudan territories. I'm talking about Sudan, like Gash Wadi, which is very important, very famous in Sudan. 95% of this of the catchment area of this catchment lies outside Ethiopia and only 5% so this really big challenge in data sharing, especially rainfall data in Zabal. is one issue they are facing. The second thing is about extreme events. We are facing this as well, and extreme events are becoming more frequent according to climate change models. These events are going to increase in the future. So I think there is a great need to incorporate climate change results into future projects. This thing I think we need to focus a lot. I just take an example of last year, this 2024, in Sudan, we experienced very severe events of rainfall, like in northern Sudan, where rainfall is almost zero. Annual rainfall is almost zero in some areas, but in those areas, in one day, we received more than 150 millimeters in just a few hours. This kind of extreme events is becoming very frequent, and this has led, of course, to severe flood damage, life and property, and even to failure of hydraulic structures. Like we have a very important dam in eastern Sudan, which collapsed last year because of this type of extreme events. So the question is, how can these extreme events be forecasted or predicted sufficient time ahead so that we can, take the necessary measures? Although in this case of dam failure, that dam was designed for spillway discharge of, say, 100-year retain period, but the flood for that year was estimated to be about 1,700 cubic meters per second. Much more than the design discharge. Regarding the modeling, I think there are great challenges, especially with the routing part of the model. But the rainfall runoff model is okay, but when we come to the routing component in a channel, this is also very challenging because of morphological changes. We have bodies which are continuously changing the morphology, not only from year to year, but even from flood to flood during the same year. We have fine changes in the cross sections and changing the sediment transportation and these kind of things. So the use of traditional routing models like Muskingum or whatever, these don't work because of these morphological changes and other issues like sediment transport, like the duration of flood is not the same. Changes from flood to flood and so on. So this is an area I think which needs further research. Just a final comment about training and capacity building. I think this is very much needed. We need to enhance capacity in this type of work, the region. And maybe a suggestion is to conduct training workshops similar to the ones we had actually, if you remember in India, in Roorkee and China, we can have training workshop which all these aspects are discussed in more details. I think that would be very useful. I think the Arab Water Council and Arab Water Academy could also help in organizing such kind of workshops. Finally, just a little comment about river-aquifer interaction and groundwater recharge in wadi systems. We have done, simple analysis in some of the wadis in Sudan where, the water balance is made between two stations, upstream station and downstream station, and just try to estimate the groundwater recharge. The result of one of our PhD students found that recharge is roughly between 5 to 10% of the river flow or the wadi flow, depending on the size of the flood. I wonder if this agrees with some of your work that you have done on this. How much roughly is the groundwater recharge? Of course, this varies from areas to areas, from channel to channel, but roughly in our case, it's from 5 to 10%. We take this as a guideline for estimating the groundwater recharge from Wadi flow. I stop here and thank you very much again. And meet again.
Thank you, Jamal.
Thank you, Professor Jamal, also for adding really for there with your good experiences there. Mr. Abdullah, do you have something quick you want to say? And
It's very difficult to add after 3 eminent professors, but I just based my experience have been always. Thank you very much for a very important lecture, comprehensive paper and introduction. My experience have been always to try to use event-based modeling when dealing with SWATs, and this, as Dr. Amin said, this is very deficient. And I mean, a lot of talk was made about the problems and the different interactions, surface, groundwater, and different physical processes that has to be modeled that are quite challenging. And I think I would like to emphasize one thing: this underscores the need for additional further research, long-term research. I think to stress out, even though it was said, I would like to emphasize it. To incorporate different emerging technologies to try to move from empirical and parameters that are used for individual wadis, like the ones which we did with Professor Jamal, to follow methodologies that can be implemented on a large scale to different wadis. And I think it's very high time to try to, people should put some effort to try to see how such difficult long-term research would be established and financed and maintained. This would be the point I would like to make. Thank you.
okay, thank you very much, Professor Abdullah, also for emphasizing the importance of research and projects. And now we open the floor for the colleagues there on the other side, the online part. Could you put up your hands for those who want to ask question or comment? And then let Howard at the end to comment or answer. So we have one hand up there. It was Shakil Ahmed, I think. Shakil, please go ahead.
Hello, good afternoon and good evening or morning, wherever the people are. It's very nice, Professor Abdin and Professor Howard Wheater, to be here and discuss the issues in Semi-Arid region. I just had, sir, one suggestion now. As the water resources system, we have done a lot of work on the rainfall runoff modeling, so we know we can estimate runoff at any point and all those things, and we have done a lot of work in the saturated zone where groundwater is there, groundwater modeling and all that. I'd like to suggest that we have to focus much more on the unsaturated zone, the Meadows zone, because that is the window for the rainfall to get the converted and recharge to the groundwater. And unless we estimate the groundwater recharge for us precisely, it is very difficult to manage the groundwater or manage the water itself in the changing climate, because the precision is very important now. So we have to focus a little more. I mean, it depends. It's complicated because the unsaturated zone, the soil moisture dynamics is much more complicated than the saturated zone. But then we have to anyway focus on that so that we can come to this simulating this soil moisture dynamics, soil moisture flow, so that we can precisely estimate the groundwater recharge. That's my suggestion. But thank you very much.
Thank you very much, Professor Shakil. Shakil is one of the GWADI, regional GWADI network in Asia, and he has great contribution in that direction. Any other hand? Dasa, please go ahead.
Yeah, thank you very much. I'm Girmay Kasa, of course, from Ethiopia, but now I am...
Introduce yourself.
Yeah. Just I am my name is Girmay Kasa, and my citizenship is Ethiopia, but now I am in Taiwan for my PhD study on hydrogeology. And then I'm participating, I think, for the second time. So this is really very important issue, of course, current issue as far as the water resource is concerned. Uh, just let me give some ideas, and of course, I will raise questions too. I think if we are talking about the arid hydrology, we have to focus on the conjunctive use of groundwater and the surface water. So whatever the modeling, all should be focused to integrate the surface and the groundwater because it is arid. Even if there are some kind of erratic rainfalls, precipitations, but because of the high temperature, it is easily, of course, lost before it reaches the groundwater. So as my colleague maybe before said, we have to focus on the unsaturated zone that can be the passage between the two resource. The other thing is maybe regarding data. Now I'm working on the long-term groundwater response to climate variability at Africa at continental level. But what I face is that there is no data for validation from the African countries. So several countries, they don't have any systematic data collection system. So how we can establish kind of water, data center system where we can use for further investigation. So as far as modeling is concerning, I think it is better if we focus, like, say, for example, of course, it has been mentioned like SWAT and mud flow that can be linked both the land surface and the groundwater. Maybe what my question is, of course, my last idea is, Professor, could you maybe have some kind of clue about I think you said Keros model. What is URAS Keros model? Can I use maybe, like, say, for example, to link to groundwater?
Okay. Thank you for your comments. In fact, all of the comments have been important and raised quite a few issues. So, Shakil Ahmed, I thoroughly agree that more work is needed on the unsaturated zone, although it's complex, particularly if you have fracture flow, and particularly given that in wadi beds you tend to have lens systems. So your particular point, you made some important points. I think conjunctive assessment of surface and groundwater is really important, particularly in arid areas, but in other areas too. I think it's important to have appropriate representation of the surface processes. I'm thinking back now to a study I did in Oman, where there was a plan to build a recharge dam on a wadi in the interior, draining from the mountains into the deserts of the Arabian Peninsula. And that was a very complex system because we had an existing affoulage system which worked very well. And then the wadi alluvium had a lot of calcrete. So it was very impermeable in places, but also fractured in other places. So to address that, we built a model which represents the processes as we understood it, which is essentially overland flow with some infiltration, and then the transmission of wadi flow down the channel with infiltration. And then we applied it, parameterized that particular situation. Kinneros is an event-based model, as Amin, I think, indicated. It does a very good job at reproducing flows from channels, from overland flow plains into channels and then routing through channels. It has a rather simplistic unsaturated zone representation. So it will be useful as a component of a model, but really you need those algorithms integrated with a more complex and realistic unsaturated zone and groundwater system. So I think there is a need for a more hybrid approach that reflects the processes more appropriately.
Thank you.
Dr. Yusri, could you please go ahead and then introduce yourself?
Okay, good afternoon, everybody. Thank you for this valuable event, which presents. I'm Dr. Yusri Khafagi, the Vice Chairman of IPAD, Egyptian Public Authority for Drainage in Egypt, and for Drain Project in Egypt. My intervention here had two, you can take two pillars, one technical and one academic, as we are dealing with the Arab Water Academy, and also in a one core pillar, which is the water resource and the hydrological, you can say, aspects of the water resources in the arid region and semi-arid region. The first one, from technical viewpoint, if we look at a shared water resource, and one of the sharing country is located in the arid region, and one in the you can say flooding area, and so I think we need to have the common understanding of the needs of every you can say country concerning the water demands for every sector and so on, either groundwater or surface water, and also the other activities related to these activities. So there should be a you can say hydro politics and the hydro diplomacy to intervene the same you can say understanding of these shared countries. This is one, to get use of all the available resources. You can say you can say win-win, to have this approach in any deal or any activity related to the water resource in every country. This is one. How to deal with it, how to make models and everything to get use of every drop of water everywhere. The other one was concerning the capacity building. If we are talking technical-wise from the shared water resource, and so academically, we have to concentrate on the second generation, third generation, and so on in these countries. As Dr. Amin mentioned, we need to build and develop and improve the capacity of those. This is not only the capacity building, but also the monitoring and evaluation system for what the impact of this capacity, which was invested on those generations, to improve the water resource management in an integrated manner within the countries themselves, to ensure sustainability. I think there should be a monitoring and evaluation system. What is the use? What did we get use of the capacity which was invested and built in those engineers, those people, those students, or whatever, or those experts? Is it come up with a beneficial, you can say, concern, a beneficial, you can say, proposal for integrating and getting use of these resources, especially when they are very limited, either through some models, mathematical models, hydrological models, and so on. Even you can, if prototypes, to make prototypes to simulate what is there on the naturally, say on ground. Yeah, thank you.
Well, thank you very much. I think there's several important points there. I think you talked about international water courses, shared water resources, the need for integrated assessment. So I point you to Amin El-Shobagi, who's in the room, who's had a number of students working on rather comprehensive modeling of the Nile system as part of the sort of water, energy, food nexus. And that kind of modeling can develop some important insights in terms of critical challenges and certainly data needs too. I think modeling can, of course, be a way of bringing people together, and the old style of working was to somebody would develop a model and say, here's my model, use it. But I think it's much more powerful if you can have co-development of models with all the interested parties involved, and then they can feel some ownership of the modeling and the product, and that's an interesting way forward. Obviously, you've got particular challenges with the Nile system. I'm not really familiar with the current status of Nile Basin initiatives, but I know that those have been very powerful mechanisms for bringing scientists and engineers together from different communities. I think probably those are the main points that you were raising, and thank you for raising them.
Dr. Abdin, may I add something, please? I mean from that we have the science, and we have the scientists, and we have the you can say the results of this modeling and so on, which led us to an action. Is there any door to make some compulsory action which made integrated, you can say the best model of integrated water resource management, which we can apply, which we can implement, which in every water resource, either groundwater, surface water, and so on. Thank you.
Yes, I think where things get to a point of impasse, then the International Court of Justice in The Hague has handled 3 international water disputes, one between Hungary and Slovakia on the Danube, one between Argentina and Uruguay on the River Uruguay, and another one recently between Chile and Bolivia. But those are really issues of last resort and tend to be decided on legal issues rather than technical issues. And on the whole, courts are not well set up or designed to adjudicate complicated technical problems. So really, there is no good way forward other than for the interested parties to come together and work together. There is a very interesting model for that, and I've done some work in mediation between India and Pakistan on the Indus Waters Treaty, and that's a treaty that was set up, brokered by the World Bank in the 1960s, and it's been a very powerful vehicle for 2 countries at times with very conflicting views to come together to work on shared water. So there's an important need for international agreements, and it would be helpful if perhaps there was more international support for brokering those agreements.
Thank you, Howard. Now we move emails. I think we give chances to other people. Manal, go ahead, please. Manal Jodat.
I'm trying to connect, but I'm trying to connect with you, but unfortunately, I don't have any anyway.
Manal, are you there?
Manal?
Yes.
Yes.
Good evening, everyone.
Yeah.
Good evening, everyone.
We want to hear
Thank you for this.
Voice, the female's voice. So go ahead, Manal.
Good evening, everyone. Thank you for these good presentations and very valuable knowledge. I think, and I agree with Prof. Howard that the remote sensing in arid and semi-arid zones is.
Manal, could you introduce yourself?
Yes.
Introduce yourself.
Manal, yes. Hydrologist Manal Daoud from Ministry of Irrigation and Water Resources, Sudan. Now I'm in Saudi Arabia. I'm in Saudi Arabia.
Go ahead, Manal.
Actually, I observed here the environment, the arid and semi-arid in Saudi, and I can judge about that. The most valuable tool, agree with Mr. Howard, that the remote sensing actually can play important role, but it needs actually very experimentations and field observations. Can be connected by land cover. I observed here through my travel in Saudi, from where to where. The land cover can play important role as indicators from shrubs to trees about the surface and service groundwater. We can take traditional knowledge from those يعني local people together with the technical tools, and we can make a good output our knowledge about this challenge. Thank you.
Well, I think that's a really interesting remark. So I did make a comment rather in passing about the need for multidisciplinary studies. And in part, it was because I had in mind issues like that. So there are issues around the ecology of the landscape and ecosystem development and response to events, which can be important indicators. So I wholly agree, and thank you for that comment.
Okay, thanks, Howard. Any other question from the kids online?
Yes, I am Mohammed El Shazli, but I would like to contact you, but it seems like no.
Go ahead.
Go ahead.
Assalamu alaikum first. Actually, it's very interesting lecture, and thank you for Professor Howard for this occasion. But I would like to add two things with my personal experience in some experiments or some studies done in the Wadi hydrology. Actually, for the problem of the groundwater recharge, I've been used the neutron scatter probe, and we drilled some shallow wells, and we are measuring by the neutron scatter probe what is the movement of the soil moisture in the ground until it reaches the groundwater recharge. This is number one. Number two, I know it is very complicated also to measure the runoff in some wadis because it's very complicated, and sometimes it needs money, people, assisting or whatever. But I found that we have used the slope area method with the Griffin gauges, and it works. And okay, we don't have a very correct measurements, but at least it gives us indication. So what is Professor Howard, his opinion about these points? Thank you.
Thank you for that. Well, we already had a comment, I think, from Shakil Ahmed about the importance of the unsaturated zone, and I wholly agree. I think if we really want to understand groundwater recharge, we have to bring all the available tools together, and at the heart of that, the unsaturated zone is really important. My own experience of that is it can be extremely complex because in wadi environments, we get heterogeneous profiles, we get layering, we have layers of fine sediment deposited by previous events and so on. And so in addition to vertical flow, we can also get lateral flow at these permeability boundaries. So it's quite difficult to interpret from one-dimensional measurements all of the complexities where we might have 2 or 3D movement. And another point is that we may, in some systems, have fracture flow or bypass flow. And in that case, the soil moisture sensors will measure the matrix, but they may miss an element of bypass flow. So I think it's a real challenging area. We absolutely do need more measurements of the kind that you're making. And I'm very pleased to hear that you're making that. In terms of the flows, I agree, it's a very difficult task to get accurate data. And if we can get coarse data, then that can be useful for scoping, as long as we bear in mind the uncertainties in interpreting the actual results.
Yeah, I think
Thank you very much.
Our time is getting very close. We will give to Sami Osman a last short comment because there is a comment at the end, and at 3 we have to close. Sami, please go ahead.
Yeah, thank you, Professor. Glad to be here. My name is Sami Osman. I'm the Regional Water Resources Engineer at NELSAP CU, part of the Nile Basin Initiative. based in Kigali. Yeah, I just want to contribute a little bit about also the groundwater, because we have several projects under NBI, specifically under NILSEC, about groundwater in the arid and semi-arid area. And we found out that not just physical tests, but also using, as my colleague Sudanese lady just mentioned, that remote sensing and GIS can also give you a better chance, a better probability. Like when we used remote sensing and GIS to locate some areas that potential groundwater, we had a success rate from 30% up to 60%. We used several, like specifically 6 parameters to identify the groundwater flow and distribution in deep aquifers. We also used multi-criteria analysis, AHP to be exact, which is analytic hierarchy process. And then the results showed us a very good map, an integrated map that shows locations of potential groundwater that can be used for water supply, for sanitation, for all the others. So I just wanted to chip in to that one, that also NBI is also working on that one. And this can also be applied, of course, in any other areas. So it's a comment, it's not a question. Thank you very much, Professor.
Well, thank you for that comment. And I think I would say that we're hearing from the audience a lot of experience of different local experiences and also different observational programs. And perhaps one of the benefits of having a meeting like this is it can bring people together to discuss their different experiences. And certainly it seems to me that would be scope for an Arab Water Council meeting to just where the participants can play a greater role in presenting their ideas and their results. Thank you for that.
Well, thank you very much, everybody. I think because of time is closing, I will give the chance to His Excellency, Dr. Hussein, just to give us a final minute.
Thank you, Dr. Abdeen, Professor Abdeen. I will add my voice to all of the participants and the commentators to thank our respected keynote speaker, Professor Howard, for this very comprehensive presentation, and already provided us with a masterful overview of the present and emerging challenges in understanding and the hydrological process. And meanwhile, it seems that our scientific journey has progressed far, but much work still remains ahead. There are a lot of things that still. And from the discussions and from the commentators, which I would like to thank them all, they brought forward diverse perspectives from our participants and reinforcing several critical themes. It seems that the urgency of bridging data gaps is one of the main things here. The necessity of coupling science with policy, then the potential of innovative tools, and the shared understanding that hydrological science must not be pursued in isolation. So with this, maybe we need, for the way forward, demands advancing regional research collaboration. It demands investing in data and technology. It demands investing in capacity building and knowledge exchange, and in science to policy translation, and fostering a multi-sector partnership. So I take the opportunity to say that let us take forward the spirit of today's dialogue into practical cooperation, sustained research, and concrete actions. In doing so, we can transform the hydrological challenges of arid and semi-arid regions into opportunities for innovation, resilience, and shared prosperity. So on behalf of the Arab Water Council, I would like to thank all once again for your participation. I look forward to the partnership and the initiatives that will emerge from today's exchange. Thank you, Professor Abdin. The floor for you.
Thank you very much, Dr. Hussein. I think now really we are coming to the closing part. I wouldn't say a lot rather than what Howard summarized at the end as conclusion. And what also Dr. Amin gave as a supporting document, we took it for Amin. And the comment which we hear from Professor Jamal, Abdullah, and from you, the participant, I did an appreciable addition to something which we can make use of it hopefully. And Howard maybe Mahmoud, maybe Jiwadi network, we may give them some note about that, which we need really to do some work in that direction. But at the regional level, definitely we'll take your wisdom and what you gave us as something which we see that it is taken for an action or a sort of action by the academy here or by others. I am really very grateful for you all and for your patience, for Howard, for this outstanding presentation as usual, for all those who commented from the colleagues, from Amin, from Jamal, from Abdullah, from you, Dr. Dr. Mahmoud, who sent it on writing, and to all of you who commented up there. I wish you all, wherever you are staying now, a very nice time. And Howard, this would not be the last. I mean, we really need your help as usual. And I know that
Dr. Abdin. Dr. Abdin.
Dr. Mahmoud, if you are in results, you are welcome. Give us
I have been watching the webinar on my way back to Cairo, and I'm very pleased. And I don't want to miss this chance to first thank Professor Witter and also Dr. Abdin and Dr. Amin and yourself, Dr. Abdin, for organizing this important and very useful webinar where we listen to the different ways and means of managing arid hydrology with the experiences from different countries. And I am very pleased to hear from Professor Witter his experiences in the different parts of the Arab world. So I hope that our cooperation will continue and work together towards improving the methodologies, the models, the means of improving data management and data measurement. And I thank you, Dr. Hussein, for taking the lead to introduce Professor Witt. And I thank you, and I don't want to keep you more, but finally, I thank you all, the participants, also those who contributed by asking questions and comment. Thank you.
Nice to hear your voice.
Thank you very much.
Thank you, Professor Witt. Thank you.
Do you want to say something?
Yes.
Lionel, or Howard, do you want to say a word or something? Or that is
just that it was nice to hear Professor Abizaid's contribution.
Thank you. Thank you very much. Thank you.
Thank you.
Thank you.
Thank you. Okay.
I would like to thank all my colleagues who did this work and all the preparation, I think, for this work. This was not
the team of the Arab.
Dr. Tariq in here, Dr. Mary, Sam,
Stephen,
Yusuf, there's those who are outside, and all of them, really. It was the teamwork, and I was so happy to work with them. Thank you, everyone.
Thank you very much. Thank you. Bye-bye.
Bye.